The optimistic, most likely, and pessimistic times of the activities of a project are given in a table. So these are the activities 10 to 20, 20 to 30. So what this means is this first activity starts at node number 10 and ends at node number 20. And the optimistic, most likely, and pessimistic time for each of the activities is also given. In this case, 4 is the optimistic time, 8 is the most likely time, and 12 is the pessimistic time for this particular activity. Now, activity 40 to 50 must not start before 22 days. So what this means is the earliest occurrence of event number 40 is 22nd day. So it cannot be before 22nd day. While activity 70 to 90 must end by 35 days. So what this means is the latest occurrence for event number 90 has to be 35th day. Now the scheduled completion time of the project is 46 days. So the management has said that the project needs to be completed by 46th day. Now we have to draw the network and determine the critical path. Also, what is the probability of completing the project in the scheduled time? So of course the management has said that complete the project in 46 days, but each of the activities has its own optimistic, most likely, and pessimistic time. So based on this time that we have calculated, we have to find out what is the estimated time duration for completion of the project, and then based on that we'll then find out what is the probability of completing the project within 46 days. So in order to determine the critical path, we have to first find out the expected time duration for each of the individual activities. So let's try to do that. So we have activity, and we have the expected time. So we know that the expected time duration is TE is equal to TO plus 4 times TM plus TP divided by 6. So for each of the activities we know TO, TM, and TP. So let's try to find out TE. So activity 10 to 20, TE will be 4 plus 4 times 8 plus 12 divided by 6, which is equal to 8. Then for activity 20 to 30, it will be 1 plus 4 times 4 plus 7 divided by 6. So 4 times 4 is 16 plus 7 is 23 plus 1 is 24, and 24 divided by 6 is 4. So the expected time duration for this activity is 4. For 20 to 40, it will be 8 plus 4 times 12 plus 16 divided by 6. So 12 multiplied by 4 is 48. 48 plus 8 is 56. 56 plus 16 is 72, and 72 divided by 6 is 12. Now for activity 30 to 50, 3 plus 4 times 5 plus 7 divided by 6. So 4 times 5 is 20, plus 3 is 23, plus 7 is 30, and 30 divided by 6 is 5. For 40 to 50, it will be 0 plus 0 plus 0 divided by 6, so it will be 0. For 40 to 60, it will be 3 plus 4 times 6 plus 9 divided by 6. So 4 times 6 is 24, plus 9 is 33, plus 3 is 36. 36 divided by 6 is 6. So this is 6. Now for activity 50 to 70, TE will be 3 plus 4 times 6 plus 9 divided by 6. So 369 is the same as activity 40 to 60, and for 40 to 60 our TE was 6, so we'll straight away put TE as 6. Now for activity 50 to 80, the expected duration would be 4 plus 4 times 6 plus 8 divided by 6. 4 times 6 is 24, plus 8 is 32, plus 4 is 36. 36 divided by 6 is 6. So TE is 6. For activity 60 to 100, again the TO, TM, TP is the same, so the expected time duration will also be the same as activity 50 to 80, so this will be 6. For 70 to 90, it will be 4 plus 4 multiplied by 8 plus 12 divided by 6. That is the same as activity 10-20, and the expected time duration was 8, so let's put 8. For 80 to 90, it will be 2 plus 4 times 5 plus 8 divided by 6. So 4 times 5 is 20, plus 8 is 28, plus 2 is 30, and 30 divided by 6 is 5. For 90 to 100, 4 plus 4 times 10 plus 16 divided by 6. 4 times 10 is 40, plus 16 is 56, plus 4 is 60. 60 divided by 6 is 10. So now we have the expected time duration for each of the activities. Now let's draw the network diagram with this information, and let's identify the critical path. So the first event is event number 10, and 10 ends into 20, so there is only one node into which the activity from 10 goes, so this is from 10 to 20. Now next activity is 20 to 30 and 20 to 40, so let's draw these. So this is the activity from 10 to 30, and this is from 10 to 40. Now the expected time duration for 10 to 20 is 8, for 20 to 30 is 4, and for 20 to 40 is 12. So we have completed 1, 2 and 3. Now next is 30 to 50. So let's say this is 50, and this is the activity 30 to 50, which takes 5 days. So we have completed 30 to 50. Next is 40 to 50 and 40 to 60. So 40 goes into 50 and 60. Now the expected time duration for 40 to 50 is 0. That means this is a dummy activity. And 40 to 60 is 6. So 40 to 60 is not a dummy activity, but 40 to 50 is a dummy activity. So this is the dummy activity. And now we have to draw the event 60. So let's say this is 60, and this is the activity between 40 and 60. So we have completed 40 to 50 and 40 to 60. Now next is 50 to 70 and 50 to 80. So 50 goes into 70 and 80. Let's draw this. So this is 70, and this is 80. These are the activities between these two events. So 40 to 60 takes 6 days, 50 to 70 is again 6, and 50 to 80 is also 6. So we have completed 50 to 70 and 50 to 80. Now next is 60 to 100. Let's draw the event number 100, and this is the activity which takes 6 days. So we have completed 60 to 100. Next is 70 to 90 and 80 to 90. So 70 and 80 both merge into 90. So let's say this is 90, and 70 to 90 and 80 to 90. 70 to 90 takes 8 days, and 80 to 90 takes 5 days. So this is done, and this is also done. And the last one is 90 to 100, which takes 10 days. So that is 90 to 100, which takes 10 days. So we have done 90 to 100 also. Now on this network, we have to identify the critical path. So we'll first identify the earliest and latest occurrence time for each of the events. Now we have already been given some of the constraints. So let's first identify those constraints. So the first constraint is that activity 40 to 50, which is this dummy activity. So activity 40 to 50 must not start before 22 days. So what that means is that the starting point, which is node number 40, the earliest occurrence cannot be before 22 days. The second constraint is that activity 70 to 90, which is this activity, must end by 35 days. So the ending node is event number 90. So the latest 90 can occur is the 35th day. So the latest occurrence is equal to 35. So now with these constraints, let's try to find the earliest and latest occurrence times for all the events. So let's start with event number 10. So for earliest occurrence, we'll do the forward pass, and for the latest occurrence, we'll do the backward pass. Now event number 10 can start on the 0th instance, so we'll say e is equal to 0. Now for event number 20, the earliest this can occur is after activity 1020 has been completed. Now activity 1020 can start at the earliest at the 0th instance, and it takes 8 days to complete the activity. So the earliest event 20 can start is 8 plus 0, which is 8. So e is equal to 8. For event number 30, the earliest occurrence will be 8 plus 4, which is 12. Now for event 40, if we look at the normal calculated earliest occurrence, so it would be 8 plus 12, which is 20. However, we have been given that event number 40 cannot start before the 22nd day. So that's why we'll continue with e is equal to 22 for event number 40. Now for event number 50, the earliest occurrence depends on the completion of activities 3050 and 4050. So event 50 cannot start until both 3050 and 4050 have been completed. Now activity 3050 will complete on 12 plus 5 17th day, whereas activity 4050 will complete on 22nd day. So event number 50 cannot start before the 22nd day. So the earliest occurrence e is equal to 22. Now for event number 70, the earliest occurrence will be 22 plus 6, which is 28. For event number 80, The earliest occurrence will be 22 plus 6, which is again 28. Now for event number 60, the earliest occurrence will be 22 plus 6, which is 28. For event number 90, the earliest occurrence will be the latest completion times between activities 70 to 90 and 80 to 90. So the completion time for activity 70 to 90 will be 28 plus 8, which is 36, whereas for activity 80 to 90 the completion would be 28 plus 5, which is 33. So activity 70 to 90 will be completing later than activity 80 to 90. So the earliest activity 70 to 90 will complete, or event number 90 can start, is 28 plus 8, which is 36. Now for node number 100, the earliest occurrence will depend on the completion of activities 90 to 100 and activities 60 to 100. So 90 to 100 will complete on 36 plus 10, which is 46th day, whereas 60 to 100 will complete on 28 plus 6, which is 34th day. So the earliest event 100 can take place is 36 plus 10, which is 46th day. Now the earliest we can complete the project is the 46th day. Now let's try to find the latest time when each of these events can be completed without delaying the overall project timelines. So for the last event, we'll take the latest completion time as the earliest completion time, which is 46th day. And now let's do a backward pass to find the latest occurrence time for each of the events. So for event number 90, we have already been given that the latest it can occur is the 35th day. Now the latest event number 70 can occur is the time beyond which, if the event is delayed, then it will have an impact on the latest occurrence time of event number 90. So latest occurrence for event number 70 will be 35 minus 8, because 8 is the duration for activity 70 to 90 to occur, and the latest event number 90 can occur is the 35th day. So event number 70 has to occur by 35 minus 8, which is the 27th day. Similarly, the latest occurrence time for event number 80 should be such that the latest occurrence time for event number 90 is not delayed. Now event number 90, the latest occurrence time is 35 or the 35th day, and 80 to 90 takes 5 days. So the latest event number 80 can occur is 35 minus 5, which is the 30th day. Now the latest occurrence time for event number 60 will be such that the latest occurrence time for the following event, which is event number 100, is not delayed. So the latest occurrence time for event number 100 is 46th day, and it takes 6 days for activity 60 to 100 to complete. So the latest event number 60 should occur by is 46 minus 6, which is the 40th day. Now the latest event number 50 can occur is the time beyond which, if it is delayed, it will have an impact on both or any one of event number 70 or 80. So for event number 70 to occur latest on the 27th day, event number 50 should be occurring by 27 minus 6, which is 21st day, whereas for event number 80, 30 minus 6, which is 24th day. So definitely, if we delay event number 50 beyond the 21st day, then event number 70 will be impacted. So the latest event number 50 can occur is the 21st day. Now for event number 40, the latest it can occur should be in such a way that both 50 and 60 are not impacted. So for 50, the latest occurrence of 40 should be by the 21st day, because the duration for 40 to 50 is 0. And for event number 60, it should be 40 minus 6, which is 34. So definitely event number 50 is occurring much earlier than event number 60. So the latest occurrence should be 21st day. For event number 30, the latest occurrence would be 21 minus 5, which is 16th day. For event number 20, the latest occurrence depends on 20 to 30 as well as 20 to 40. So for 20 to 30, the latest occurrence of 20 should be 16 minus 4, which is 12th day, whereas for 20 to 40 should be 21 minus 12, which is the 9th day. So 9th day is the earlier. So latest event number 20 can occur is the 9th day. And for event number 10, the latest it can occur will be 9 minus 8, which is the first day. Now with this information, let's find out the slack of each of the events. Now slack is the flexibility available for each of the event to be rescheduled without impacting the overall duration of the project. And slack can be calculated by the latest occurrence minus the earliest occurrence, and that is basically the flexibility available. So here slack is equal to 1 minus 0, which is 1. For 20, slack is equal to 9 minus 8, which is 1. For 30, slack is 16 minus 12, which is 4. For 50, slack is 21 minus 22, which is minus 1. So we'll understand what does minus 1 mean a little bit later. So for event number 40, slack is equal to 21 minus 22, which is again minus 1. For event number 60, slack is equal to 40 minus 28, which is 12. For event number 70, slack is equal to 27 minus 28, which is again minus 1. For event number 80, slack is equal to 30 minus 28, which is 2. For event number 90, slack is equal to 35 minus 36, which is again minus 1. And for event number 100, slack is equal to 46 minus 46, which is 0. So basically what this means is that if you have a slack of 1 day, that means that even if we delay the occurrence of event 20 by 1 day, the overall completion of the project will not get impacted. Now a slack of minus 1 means that there is less time available to complete an activity or an event than what is required. So that makes an activity or an event a supercritical activity or an event. So in such situations, basically a decision needs to be made as to how to compress the duration of the activity so that we can still complete the project on time. So all the events having a negative slack indicate that the activities between them are supercritical or would definitely be on the critical path for this project. So let's first identify the events which have a negative slack. So this is one event, this is second event, this is third, and this is the fourth. So the activities between these events are definitely critical or supercritical activities. So let's identify those. So 70 to 80 is on the critical path. 50 to 70 is also on critical path. 40 to 50 is also on critical path. Now event 100 has a slack of 0, so this will be also on the critical path. So now what we have is 40 to 50, 50 to 70, 70 to 90, and 90 to 100. Now from 40 to 10, the activities will be on critical path. So 10 to 20 is on critical path and 20 to 40 is also on critical path. So this duration is 12. So our critical path is 10, 20, 40, 50, 70, 90 and 100. And the duration of the project will be 8. Basically it will be the duration of the critical activities, plus 20 to 40 is 12, plus 40 to 50 is 0, plus 50 to 70 is 6, plus 70 to 90 is 8, plus 90 to 100 is 10. So 8 plus 12 is 20, plus 0 is 0, plus 6 is 26, plus 8 is 34, plus 10 is 44. So based on the critical path and the duration taken by each of the activities, the duration comes out as 44 days. However, because there are certain constraints given to us that certain events cannot start before a certain time period, the overall duration came to 46 days. So the project, the earliest and latest completion time for the project is 46 days. So we'll continue with the duration or the expected duration is equal to 46 days. So this is the TE. So based on the critical path and based on the network diagram calculations, our expected duration comes to 46 days. And in the example given, the management is asking us that the scheduled completion time of the project is 46 days. And what is the probability of completing the project in the scheduled time? So now if we draw the normal distribution curve, the mean, which is TE, is 46 days, and we are being asked to find the probability of completing the project in 46 days. So now the probability will be the proportion of this area as compared to the entire area under the curve, which is basically 50%. So the probability is equal to 50% for completion of the project in 46 days.